So you need help with number 5. If you didn't catch it, the balanced chemical equation at the top is the answer to number 3. So if you're struggling with this, you might want to check your answer there. So number 5, how many moles of acetylene, that's C2H2. So how many moles of C2H2 was burned if 110 grams of carbon dioxide are produced? So we're going to look at the amount of carbon dioxide we got in the end and try and figure out how much we burned. And using stoichiometry, we can actually do those calculations. We don't actually have to measure out how much did I burn, how much carbon dioxide did we produce. We can calculate it back and figure it out. And so that's one of the reasons we're doing stoichiometry. That's the purpose of this. So, if you ask me how we use this in the real world, the answer is you probably won't, but if you're going in chemistry, this might be useful. Anyway, let's look at what we're starting off with. We're starting off with grams of carbon dioxide. Let's focus on the units first. So grams of carbon dioxide to moles of acetylene. Well, if we try to use our graphical organizer over here, grams is a measure of mass. And we're starting in carbon dioxide. So let's claim this side of our graphical organizer in the name of carbon dioxide. So, we're starting with grams of carbon dioxide. We're going to moles of acetylene. Now, we can't use this moles because this moles has been claimed by carbon dioxide. We have to use the other set of moles. So, moles of acetylene will have to be on this side of our graphical organizer. All right. Now, let's try to actually calculate this out. Let's see, we got 110 grams carbon dioxide. We're going to multiply by a conversion factor. Actually, we're going to multiply by 2 conversion factors. We know we have 2 conversion factors because there are 2 arrows that take us from mass up to moles over to moles. That's 1 arrow here, 1 arrow here. That means we need 2 conversion factors. Our first conversion factor takes us from mass to moles, and it's mass to moles of carbon dioxide. All the things on this side are carbon dioxide. So that means it's the mass of carbon dioxide on the bottom, because we want that to cancel out, and moles of carbon dioxide on top. Our second conversion factor takes us from moles of carbon dioxide over to moles of C2H2, acetylene. So we'll put moles of carbon dioxide on the bottom and moles of C2H2 on top. All right. Going back to that first conversion factor, let's fill in the numbers now. Grams to moles of carbon dioxide, that's a molar mass problem. Anytime you go between moles and mass, it's molar mass. So we've got 1 carbon and 2 oxygens. We need to look up the mass of a carbon and an oxygen on the periodic table. When you do so, we have 1 carbon. Each carbon is 12.01. 2 oxygens. Each oxygen is 16. 1 times 12.01 is 12.01. 2 times 16 is 32. And now we've got it set up for an addition problem. 1 plus 0 is 1, 0, 4, and 4, 44.01 grams of carbon dioxide are in each mole of carbon dioxide. So that means this number here, 44.01, goes down here with grams. And that's how many grams are in 1 mole of carbon dioxide. All right. The next thing we have over here is taking us from moles of carbon dioxide to moles of acetylene. That's a mole ratio, moles to moles problem. So for mole ratios, we look at the balanced chemical equation at the top that you did for number 3. And we're going to look at the coefficients. So let's start with carbon dioxide. What's the coefficient on carbon dioxide in our balanced chemical equation? We look up here, we see there's a 4 next to carbon dioxide. So that's the number we're going to put here in our mole ratio. We look for acetylene now, C2H2. We see that there's a 2 on acetylene. I'm going to put a 2 right here then. All right. All the numbers, all the units have been set up. We just need to do the math now. Let's see what cancels out, see if that can help us. Grams of carbon dioxide cancel out with grams of carbon dioxide. Moles of carbon dioxide cancels out with moles of carbon dioxide. I think that's everything that cancels out this time. So I'm going to write this down here to give us a little more room to hopefully space it out, make it easier to see at home. So we have, over on the left, 110. That canceled out. Times 1 is itself, so we don't need to actually do that math. That's still 110. Moles of carbon dioxide canceled out. Times 2. Moles of C2H2. Over 44.01. Well, grams of carbon dioxide cancel it out, times 4 moles of CO2 cancel it out. This is all that's left. Let's break this down into, let's do the math on top and the math on the bottom, then we'll divide. So 110 times 2, you can use a calculator, you can do the math in your head, it's 220 moles of C2H2 over 44.01 times 4. We'll do it in the calculator. Yeah, 176.04. Alright, so we multiplied the two numbers in the numerator, got 220, multiplied the two numbers in the denominator, got 176.04. The next thing we can do is divide. So 220 divided by 176.04. I can't do that in my head. If you can, that is incredible. But we'll do it in the calculator. And we'll get 1.25 moles C2H2. Alright, so we were asked if this is how much carbon dioxide we got out, 110 grams, how many moles did we burn? Well, it turns out we burned 1.25 moles of C2H2. So, that is your answer for number 5. Hope you all are doing well, and you'll see me in another video probably.